Okay, dear students, so coming back to this same thing that we did in the first video, the hydrogen spectrums, and let us try to explain them now with the help of Bohr's theory. What is happening? So, first of all, like this is the nucleus, shell number 1, shell number 2, this is shell number 3, shell number 4, like that. Now, if some transition is taking place with respect to n is equal to 1, like Lyman series I'm talking about, that the electron is either jumping into n1 or it is jumping from n1. Like if the energy, there is an electron here, let's say, if it absorbs some energy, this electron is going to jump into 2. Clear? Now, if there is already an electron here in 3, let's say, it wants to jump back to n is equal to 2, it will be releasing some energy. So this release of energy will be creating emission spectrum, and this absorption of energy would be creating absorption spectrum. Clear? First of all, we have to understand this. Now, Lyman series means that either the electron is absorbing energy and jumping from 1 to higher energy levels, or you can say there is some electron in the higher energy level and it is literally jumping into 1. So if it is coming back to 1, even then it is called Lyman series, but that will be the Lyman series for the emission spectrum. Getting my point? Now, we are not interested in Lyman series at all in this. Like, why are we not interested in Lyman series is because we are using the visible range here. So visible range is created only in Balmer series. So we have not chosen Lyman, but we have chosen the Balmer series instead to teach students. So it's not that in the case of hydrogen, the Lyman series is not there. It is there. The Lyman series will be there in that region, but that will be ultraviolet and obviously you can't see it. So they will not be visible. But for our study purposes, Balmer series make a very formidable visible. You are able to see what is happening. So we are concerned with, let's say, absorption spectrum. First of all, so the light is falling on an electron in n is equal to 2, and this electron is jumping into either n is equal to 3 or it is going into the higher energy shells n is equal to 4, 5, 6, like that. So when this kind of a thing is happening, absorption spectrum will occur. If the reverse of that is happening, like let's say the electrons are jumping from like 3 to 2, and then there is an electron jumping from 4 to 2. So in this case, emission spectrum will be created, and which will be looking somewhat like this. Number one, this point must be clear. Why are we using Balmer? And like we are not using Lyman, so students will be confused with that first of all. So that confusion is over. We are using the Balmer series. Everything either start at n is equal to 2 or the transition is ending at n is equal to 2. Now this first line, which is happening here, this is called H alpha line. Even in the absorption spectrum, we call it H alpha. We call this as H beta. The next one will be H gamma, delta, like this. So all these radiations, all these things, they are arranged in this fashion. So H alpha is pertaining to when the electron is jumping from 3 to 2, or vice versa, it is going from 2 to 3. Beta will come into picture if you are going from 4 to 2 or 2 to 4, and this is coming, gamma is coming if you're going from 5 to 2 and 2 to 5. Okay, so this is how they are arranged, and according to all the formulas which are given by Balmer, given by Bohr, like you are finding the energy for the shell number 3, then you find energy for shell number 2, and then you subtract it, you find delta E, and you equate it with Hc by lambda. So in the case of H alpha, theoretically also you are getting this wavelength, which is 656 nanometer. So theoretically we are getting the same answer, which is 656 nanometer, and literally it overlaps with the experimental evidences. So at least in the case of hydrogen, we can clearly say that Bohr's theory scores very well. So this is really like this theory is accepted. At least for hydrogen atom, it is accepted. For others, because there are too many electrons, there will be too many lines. And so obviously there's a lot of confusion, and we actually don't know where the electrons are placed. So we're not going into the higher elements, but for hydrogen, Bohr's theory does the job. Now, after this, I think this is clearly understood. Another very crucial point about the Bohr's theory, that is one of a very good takeaway, is that when he talks about the stationary orbits, he says that the angular momentum is found to be integral multiple of h by 2 pi constant. Now, the question is, why is that? The second postulate was about stationary orbit. Now, when people started asking Bohr, like, why is the concept of stationary orbit there? Why the electron is not emitting energy? There was no answer. These two questions, they were unanswered. Why is this happening? We don't know. So this was supposed to still there was no supporting theory, I would say. Now this supporting theory came into being only in 1922 when Louis de Broglie came into picture, and he gave the theory about matter waves. So matter waves is a topic that we are going to cover in E2. So don't worry, that will be covered in E2. He gave a supporting theory for this phenomena, like why the angular momentum is given by nh by 2 pi, and why is the concept of stationary orbit valid there. So that was not given by Bohr, but it was given by Louis de Broglie in 1922. So that we will see in E2. So these were two major takeaways from Bohr's theory. And number three that we can say is that yes, the concept of nucleus, which was given by Rutherford, was accepted by Bohr, is still correct. So there is no problem. We still believe in the same thing. We still accept that theory. Okay, dear students, so with this, I think the topic even is completely closed. There is nothing left there. There will be a couple of questions I would be giving you after this. They're very important, and you can watch those videos also. There is a special even question bank playlist also that is created for you. It's already ready with kind of like nearly 16 questions or something. You people can go there and watch all the questions. Okay, student, thanks for watching. All the best. Bye.